Hi everyone, come write a code with me in order to develop the SV Testbench environment. So in today's video we are going to write a code together and we are going to develop the entire Testbench environment. Right, like we are going to write the codes for every block uh, in the upcoming sessions. So, if you already know about the system Verilog test bench architecture, it is fine. If you don't know how to develop a test bench architecture, or if you don't know about anything related to SV test bench, then I'll link the two videos below where I have explained clearly like how we are developing the SV test bench architecture and what are the basic things we need to know before writing the SE test bench code or before developing the test bench environment. Okay, you first please check out those two videos before and then come to this video where we'll be writing the code together. Okay, so if you know this test bench architecture, we already know that this the first block includes the test bench top. Okay, so test bench top is nothing but this is the topmost file which connects this DUT to the TB. Okay, so this is my DUT and this is connected to my TB with the help of an interface. Right. So when you are writing a code for test bench top, you should include test cases, interface and DUT. So these are the three instances that you need to write in your test bench top. Okay, so in today's video we are going to write a test bench top code. Okay, so after writing the test bench top code, then we'll be going inside the environment. Like then we'll be starting how to write a code for transaction, generator, driver, interface, duty, everything. Okay, so in the upcoming series you are going to write a code along with me and develop the entire test bench environment for an adder circuit, right? So if you are new to this channel, consider subscribing my channel and hit on the notification bell. Also please do share this video to all the VLSA aspirants who also want to enter into design and verification domain, right? So getting on to today's video, as I told you, first we are going to write the test bench top and then we will be going inside the environment. Why is it? Because test bench top is very familiar to you, because if you know how to write a Verilog code, then the test bench top also includes the same things. Like if you know how to write a test bench Verilog test bench code, then it is easy for you to understand the test bench top. So that is why first I am including the test bench top and then we will be going to the inner blocks like transaction, generator, driver and all. So before going into test bench top, before writing the code for test bench top, let us see the RTL code. Okay, so why if you already know about Verilog codes, you know how to write a basic adder code, right? So let us see what does your basic adder code consists of. If you see here, okay, module adder, and since you are developing it in a system Verilog architecture, so obviously you need clock and reset. Okay, and then since this is the adder, so you need obviously two inputs which are A and B, and if you see here both are of 4-bit wired. So okay, so A and B both are 4-bit wired, that means it's a 4-bit adder, and then one valid input. Okay, basically you will be adding this valid input in order to have control on adder. Like if this valid is high, then it works as an adder. Okay, so in order to have some control on your adder design, you are using this valid input, right? And then output, obviously since these are 4-bit wired, so obviously the output will be more than that, so that is why I'm just taking it as 7-bit wired, like 6 down to 0 C. Okay, so these three are the inputs and valid is one more input, and then obviously clock and reset are inputs, so output is C. Clear? And then I am taking one more additional variable like temporary C. Okay, TMPC, this is one more variable just in case if you want to store, if you are losing some value in the output, if you are having some spare value, so that it will be useful for you. So that is why I am storing that spare variable. I am taking the spare variable, I am storing the output value in the spare variable also. Okay, so these are the things. Now first I am initializing the temporary C. That means if always at the rate of percentage of reset. That means if reset is high, then the temporary C value is initialized with value 0. Okay, just in case. That means I'm just giving the default value for temporary C, so that if there is any garbage value in it, it will be removed, right? And then I am going for actual code, which is always at the rate of percentage of clock if valid. That means if valid is 1, then the operation, what is the logic? Within temporary C, I am storing the value as a plus b. Whatever that is gone for a and b, it will be added, and then it will be stored in the value temporary C. And then from temporary C, I am using the assign. Okay, with by using the assign, I am just assigning the value from temporary C to the actual output value, which is C. So this is the basic logic that I am writing for my adder. Okay, instead of using this temporary C, you can just give it as if valid C equal to a plus b. That is also fine. As I told you, in order to have some spare values, I'm just taking this extra variables, right? So this is my basic code. Now what we are going to do, we are going to write a first test bench code, test bench top code for this particular uh, values. Okay, so as I told you, what is our first if you see in the before figure, as I told you, what does our test bench top consists of? It consists of test and dut, and then test and dut are connected it through interface, right? So that means first you will be using the handles for both. You will be including both the test cases and then interface. So what you will be writing? Tick include. By using the tick include option, tick include what you want to include, interface. Okay, so you are including the interface file, which is interface.sv. Okay, and then tick include. What else you need to include? You need to include the test case. So for this, basically I am writing a test case. Okay, you will also be writing the test case, and the title of this test case is random test. Okay, so random test.sv. So these are the two things I am including in my test bench top. Okay, in this way only, in whatever block, if you want to write, if you are writing an environment block, you need to include generator component, you need to include the driver file, you need to include the transaction file. Similarly, so test bench top consists of test file and interface. So I am including those two files, interface.sv, random test.sv, right? Now the actual code begins. So what is that? Since if you see, this is the test bench top, this is the only block which is written in module. Okay, now the remaining entire things are written within the class based. Only test bench top is module based. So basically module, okay, I am writing it as some name like tb top. This is my name. Okay, now what is it along with within the test bench top? Basically when you are writing the Verilog code, what are the things that you will include? You will be including first, you will be including the clock and reset. The same things you are including here also, like first bit clock, okay, and then bit reset. Okay, so these are the two things that I want to include, right? So now after declaring the clock and reset, what I'll be doing? I will be generating the clock. So you already know how to generate a clock. Always, okay, hash 5. So for every 5 clock cycle, clock equal to negation of clock, right? So this is how I'll be generating the clock. In any place you will be generating the clock in this way only when you are developing a Azure test bench, right? Now I have generated the clock. Now next is what? I will be generating the reset. So how you will be generating the reset? Initial, because reset needs to be first, you need to reset any design, you need to reset it once. Okay, so that is why I'm writing it in initial block always, because clock needs to be maintained always, but reset is not like that. Every time you don't reset, right? For after every clock cycle you don't reset, so it will be written within initial. So initial begin, right? Reset equal to, I am resetting it once. Okay, and then after resetting it, after hash 5 units, I will again hash 5 or hash 10 at any time period, you will be resetting it to 0. Okay, and then you will be ending. right? So this is the how you will be resetting your reset. Okay, so this is my clock generation, this is my reset generation. This is how you will be resetting the your reset, right? And then, so apart from this, what are the things that you need to do? Now you have generated the clock, you have generated the reset. Next, what is it? So after clock and reset generation, what are there along with this? What are the things that are present? You need to connect the test to DUT through interface. So that means what you need to do, you need to create the handles, you need to create the instances for interface. Okay, so you already know that I have included the interface file here. So that is why whatever name I have given with the interface, okay, you will be seeing that in the interfaces. For example, let us think we will be starting it with INTF. Okay, so for this INTF, I am creating the handle. So what is the handle? I am just giving it as INTF. INTF. Okay, so this is my actual interface handle. Sorry, this is my actual interface name. Okay, for this I have created the handle I_INTF, for example. So in upcoming sessions also, when we are writing the interface, we need to give the name as INTF. Okay, so we'll be talking in deep about this interface when we are writing the interface code. Don't worry about that. Again, after writing the interface code, then we'll come here and we'll discuss about this also. Okay, so INTF of, I'm creating the handle as INTF. So in the interface, basically when you're writing the interface code, what you will be including, you will be including all the input and output signals. So what are the input signals here? A, B and valid are the input signals and C is the output signal. Basically in interface you will be including only input and output signals. But along with this input and output signals, in your Testbench top, you are having two more signals which are clock and reset. Okay, so you want to include, if you are going to include this in the interface, what you can do? So how you are going to do it? I_INTF of clock and reset. That means along with the handle, along this with the handle, this is shared with all the inputs like A, B, valid. Okay, for all this A, B, valid and C, this particular handle is shared INTF. So along with those, you are adding two more things which are clock and reset within the braces, like just you are giving it is in the form of arguments. Okay, so this is how you will be creating the instance for the interface. Okay, now you have created the instance for interface. Now what is the other thing you need to create? For instance, you need to create the instance for test cases, right? So what is the test case? Okay, so you are writing it as test, you are also taking the test case handle as T1. So interface handle is passed to test, right? This is my interface handle, this interface handle is passed to the test as an argument. Clear? So this is how you will be writing the interface and test cases within your Testbench top. Okay, if you don't understand also, don't worry, because once you will be knowing how to write the test cases and the remaining things, then you will understand about the things. Now what we need to do? Okay, until now what we have done, we have generated the interface and then we have created the random test files and then we have created the clock and reset for Testbench top and we have created the handles for test and DUT. Now what we need to do? We need to connect this Testbench top to the DUT. How are we going to connect these two things? Like Testbench top should be connected to DUT. How are we going to connect these things? Just like how you connect it in the Verilog Testbench code. So in you will be writing the DUT instances. Okay, so what is my particular code name? If you see, this is adder. So adder, okay, adder of DUT equal to, so what are the input signals here? Clock, reset, A, B, valid, right? So for all these things I will be creating the instances. Clock of, so with the clock, what is the interface handle? I of INTF. So with the help of interface handle I am connecting it to the DUT clock. Okay, next reset. So with this is the test bench reset, and then I am connecting it to the so this is DUT reset, I am connecting it to the test bench reset. Okay, similarly, what are the things again? A of int dot a. Next, so for everything you should need to set a comma, right? Now dot b of intf dot b. Next, dot valid of I of intf of valid. What else? Dot c of I of intf dot c. So in this way you will be creating the instances. You will be creating the DUT instance for all the signals that are present in your RTL code. Okay, now you have connected the RTL to your DUT. So that is all you will do. And then end module. Okay, so this is the thing basically you will be writing in your test bench top code. Okay, now by doing this you can see the output in the log file. But if you want to see a waveform, basically when you are writing, when you are executing this in the EDA playground, you will be seeing the output in the log file. But if you want to see the waveforms, what you will be doing, you will be enabling the wave dump. So you will be writing a dump file in order to see the waveform. That dump file will also be included before the end module. Okay, we'll be seeing what is how to write a dump file in the upcoming series, right? So this is how you will be writing the test bench top code. And hope you understood about how to write this test bench top code, right? If you don't understand this, please comment me in the ping box, so that about your doubts, so that if you are having any doubts related to this, I'll definitely answer it in the upcoming sessions, right? So this is all for today. If you like this video, you know what to do. Please do like it and also share it to all the VLSA aspirants. So that is all for today. Thank you.